Hi everybody, and thanks for checking in. This lesson that we're going to do today, as you can see, is lesson 9-6 in your textbook. It can be found on page 499 if you want to follow along. Paper and pencil and calculator as usual, please. So, we've been working with exponents a lot in this unit, and we've been working with monomials. We're going to continue our investigation of exponents with monomials today. Now wait, before we get started with this particular lesson, I just want to do a quick little review of some things that we've been doing with monomials and exponents. Let's remember that when you are multiplying monomials with the same base, such as these, the base stays the same, and we added the exponents, right? So when you're multiplying monomials with exponents that have the same base, we add the exponents. When you're dividing monomials with the same base with exponents, do you remember what we did? We subtracted the exponents. So when we were dividing, we subtracted the exponents. When we were multiplying, we added the exponents. Well, today is different yet. Today, we're going to have monomials, such as, I don't know, this, with an exponent, like so. All of that with another exponent on it like that. So these are powers of monomials, right? Monomials that have exponents that then have another exponent on top of that. And what we're going to be doing today is not adding the 2 and the 3, is not subtracting the 2 and the 3. It's going to be multiplying. So, powers of monomials. That again means an exponent that has an exponent on it. So, to find the power of a power, right? An exponent on top of another exponent. The trick is to multiply the exponents together. So I have some quick examples here. The first monomial we have is 4 to the second power. All of that being raised to the 5th power. So we take 2 times 5, and that's how we get 4 to the 10th power. Because if I were to break this down for you step by step, here's what it means. What does 4 squared mean? 4 squared means 4 times 4, right? That would be if you had that to the first power, if you only had one of those. But we have 5 of those. So you would continue this on. There's 2 of them. There's 3 of them. There's 4 of them. There's 5 of them, and they're all being multiplied together. How many are there? Count them. There's 10. That's how this works. It's 4 to the second power, and then you have that 5 times. So it's 4 to the 10th. Same thing down here. N to the third power, all being raised to the second power, which would mean here's n to the third power. That's one of them. But you have 2 of them. And how many is that all together? 6 n's. So n to the 6th power, or n to the 3 times 2. So again, when an exponent has an exponent, you multiply the exponents. Okay? Let's try some. So 9 to the 6th power, all being raised to the 2nd power. That's 9 to the 6th times 2. 9 to the 12th. 4 to the 3rd to the 7th is 4 to the 3 times 7, 4 to the 21st power. 2 to the 3rd, all to the negative 2nd power. So imagine 2 to the 3 times negative 2. What does that give you? That gives you 2 to the negative 6, which, do you remember? Not allowed. Where does it go for its attitude adjustment? Down to the basement. So this is what you would have to do with this one. You'd have to send that one down to the denominator of a fraction so that it would then have a positive exponent. And that was from one of our previous lessons. Always, always, always multiplying the exponents when it's a power being raised to another power. Let's continue. These are variables. N to the 4 to the 4th. N to the 16, right? 4 times 4 is 16. Q to the 4th power, all being raised to the 5th power. Q to the 20th. How about this one? Oh, this one's interesting. So it's 5 r to the 7th power, and then everything in there is being raised to the 2nd power. So guess what? This is kind of like the distributive property. You have to take this guy on the outside and give him to the 5 and give him to the r to the 7th. So it becomes 5 to the 2nd power, r to the 14th power, and at this point, if you can solve part of it, you should. And can you solve part of it? Yes, you can solve this. 25 r to the 14th power. So scrolling down here, looking at these, we have quite a few on this page, so I'll scroll down, disco. All right, so again, it's kind of like the distributive property. You got to give the 4, this exponent has to be distributed to all 3 pieces of this monomial. He has to go to the 2, he has to go to the x to the 6th, and he has to go to the y to the 3. So it's going to be 2 to the 4th power, x to the 24th power, and y to the 12th. Because don't forget, we're multiplying. 4 times 6 is 24, and 4 times 3 gives us 12. Now, do you see anything here that you can solve? You can solve that. 2 times 2 times 2 times 2 is 16. X 24, Y 12. Same thing down here. Give that 5 to the 6 and to the W to the 4th. So it's going to be 6 to the 5th power, W to the 20th. And as far as 6 to the 5th power, you could solve that, but it's a pretty large number. So I'm going to say this. I'm going to say that this is an acceptable answer. And how will you know when you should solve, like we did in the previous problem? We solved 2 to the 4th and we got 16. And then on this one, I'm saying that 6 to the 5th power, you can just leave 6 to the 5th power. How will you know when to leave it and when to solve it? Well, I'm going to tell you this. If it's a reasonable number, like 2 to the 4th power is 16, that's a reasonable number to work with. 6 to the 5th power is a very large number, too large, in fact, and I wouldn't expect you to calculate that out. So, you know, if you were to solve it and write that big, huge number, I'd be okay with that. But if you want to leave that one 6 to the 5th, I'm all right with that because that's, like I said, that's a pretty big answer. Let's do some more. Okay, this outside exponent of 3 goes to all 3 pieces of this monomial. It's going to go there, it's going to go here, and here. So that's a -4 in parentheses to the 3rd power. That's an s to the 15th, and that's a t to the 21. Now, yes, you have to use parentheses. -4 times -4 times -4. If you should choose to work it out. Or, you know, technically you could leave your answer the way we have it written there. But if you do choose to work it out, it's a -64. S15, T21. I would probably allow that, and I would probably allow that. I would probably say either answer is fine. Okay, this is actually the last problem we're going to do in this lesson, and then you're done. Let's go back to red. I don't know why, but let's. This 2, ready? Give them to everybody. He goes to the 3. He goes to the x to the -2. And he goes to the y4. So it's a 3 to the 2nd power, x to the -4. That might be something we have to deal with. And y to the 8th. What can I solve? Well, what's 3 to the 2nd power? It's not 6, it's 9. what would you suggest I do with x to the negative 4? How about this? Send him to the basement for his attitude adjustment, right? So that he can become x to the positive 4. What about y to the 8th? He can stay upstairs with the 9 because he's not negative, right? So the 9 becomes part of the numerator of the fraction, the y to the 8th power becomes part of the numerator, and x to the negative 4, we sent him downstairs for an attitude adjustment so that he could then have a positive exponent. So this is our final answer. So I guess for a good rule of thumb, if you have a number with an exponent like negative 4 to the 3rd power, or 3 to the 2nd power, or 2 to the 4th power, and you can solve those, solve them. If it becomes some really big number that's unmanageable, then you don't have to. But all in all, if you can solve it, then I would suggest that you try, that you go ahead and punch it in your calculator, see what you can come up with. So these are the problems we're going to be working on in class. That's 9 through 22, all problems, and then 48 to 50 will be a little bit of a review. Okay? I will see you in class.